Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is binary modulo, and it is an easy level problem. So this particular problem says that we have been given a binary string s and an integer m, and we need to find the value of k mod m, where k is the binary equivalent of the string s. Binary equivalent means if you convert the string s into decimal, then it will be equal to the value of k. So we basically have to find k mod m. Right. So let me just quickly discuss the first sample test case, what it says. So the question statement is, I believe, pretty straightforward, and there is like nobody will have difficulty in understanding the problem statement. So if this is 1, so this is 0th index, this is 1, this is second. So 2 raised to power 2 is 4 plus 1, this is 5. So we basically have to calculate the value of 5 mod 2, and this is equal to 1. Right. So this is how we can find our answer of this particular problem to be 1. Right. Now this is the problem statement is simple, but the only problem that that exists here is that the value of the origin string s, its length is equals to 10 raised to the power 5. Right. So while computing, there will be 10 raised to the power 5 places here, and the last place will contribute to 2 into 10 raised to the power 5 minus 1. Right. So we definitely can't compute such a huge number. This is out of bounds for any data type. Right. So we need to think of some clever method to compute this value of k mod m. Right. So we will utilize some of the most simple yet powerful techniques of modular arithmetic. So you'll see that if like we want to find the value of a mod m, right? So you will realize if you are able to break it into two parts, like you can break it into b and c such that b plus c is equals to a. Then you can also compute it as b mod m plus c mod m whole mod m. Right, the answer will be the same in both of the cases. Again, if you have some number, let's say z, right, and it is equals to p into q. So z mod m can be represented as p mod m multiplied by q mod m whole mod m. Right, so this is what we are going to use. Now every binary number that we know of, like the binary number is like this, it is represented as a summation of power of 2's. So if this is the 0th index, 1st index, 2, 3, 4. Let us take some example of a binary number. So let's say this is 0, 1, 0, 1, 1. So it will be represented as 2 raised to the power 4 plus 2 raised to the power 3 plus 2 raised to the power 1. Right. So it is a summation value. Right. Now what we can do is we can obviously use this particular method to like compute them separately. So we basically have to compute 2 raised to the power 4 mod m plus 2 raised to the power 3 mod m plus 2 raised to the power 1 mod m. Right. So we have utilized this particular technique to break it into 3 different parts. Now since this individual value can also be pretty large, we are going to use this second technique to divide it into smaller parts. So what is 2 raised to the power 4? It is 2 into 2 into 2 into 2. Right, mod m. So it is just 2 multiplied 4 times. Right. So you can apply modular arithmetic at each stage. You can do 2 mod m multiplied by 2 mod m whole mod m multiplied by 2 mod m and then again whole mod m multiplied by 2 mod m because there are 4 2's and again whole mod m. Right. So this process can be pretty long, and we are going to see how we only have to compute the last part at each stage. Right. We don't have to compute the previous part. We'll just have to compute the last part at each stage. So what we'll do is we will maintain a current variable. Let's say we have current, which will be storing the current power of 2. So initially the value of index is 0, so the current power of 2 is 1. Right. Now I'll also initialize my answer with 0. Right. So basically we have to compute this particular value for all places where the value of the string is equals to 1. Right. We have to add this particular value in our answer depending on the value of I. Right. So what we do is we initialize our answer with 0 and our current with 1, right? So first of all, if the value of s of I is equals to 1, I'll add this particular value current to my answer. So if s of I is equals to 1, I'll add this value to my answer. So what I'll do is answer plus current mod m, right? And like in any case, even if it is 1 or it is not equals to 1, there is one thing that we'll definitely do, that is current is equals to current into 2 mod m, right? So why is this particular step important? So you see, at each step we are not going to calculate the whole thing, we are just going to calculate the last part. We are just going to multiply the last part and taking mod m, right? So at each step we will not have to compute the previous part, because the previous part will already be stored in the current variable, right? We'll just have to add the last part of the powers of 2, that is multiplying the current value by 2 and taking mod m, right? Since the value of m is up to 100, this current value can be at max 99. So 99 into 2 will definitely fit into our integer range, right? So this is what we have to do. I've explained, let me just quickly summarize what I just said. We are going to use two different properties of modular arithmetic. So any binary number can be written like this, right? So we have used the first property to expand it like this, right? To like write it as different summations. But the number itself, that 2 raised to power I, can be pretty huge. So I wanted to break it into even smaller values. So it is 2 multiplied by itself 4 times modulo m. So we are going to use the second property to find out its value. Now at each step I am multiplying mod m, right? And the answer will still be the same if I multiply it at the end, and if even if each step I will multiply it by mod m, the answer will be still the same. So computing the value of this whole portion every time I encounter an index I will take too much time. So what I'll do is I'll store the previous value in a variable called current, and I'll just append, or I'll just multiply the last with the last value of 2, right? So at each index my current will get automatically updated. So what I do is for every index where s of I is equals to 1, I'll add the value of current to my answer, taking mod m, and like what I'll do is, even if the s of I is 0 or 1, whatever is the case, I'll multiply my current value with 2, because I'll have to update this particular value, right? This has to be updated at each step. So for 0th index it will be 1, for the first index it will be multiplied by 2, for the second index it will be multiplied by 2, for the third index again multiplied by 2. So this will keep on going on, right? So at each step I have to apply this also. So if I do these two things, my final answer will be stored in the answer variable, right? And it will be obviously like computed according to the modulo. Now let us have a look at the code. So this is the small code that I have written. I have initialized my answer with 0. I have reversed the string s because the rightmost digit is the least significant bit. So I wanted to compute it first. That is why I have reversed the string. Now I initialize my current variable with 1, and I just traverse through the string. Whenever s of I is equals to 1, I just increment the value of my answer by adding the current value to it, right? Now I update my current value by multiplying it by 2 and taking modulo m. So this would be the solution of this particular problem, and at the end I can just return my answer. So let me just quickly submit this code, and let's see it works or not. So you see that this code passes all the test cases, and I hope that you guys were able to understand the solution. This was all about today's problem of the day, binary modulo. If you guys were able to understand the solution, then don't forget to drop a like on this video. It's really helpful for the YouTube algorithm to understand that you actually found some value in this video. And I see a lot of people who watch these videos regularly have not subscribed yet. So if you're one of them, do consider subscribing to this channel. Share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.